Use the properties of logarithms and the logarithm property of equality to solve the logarithmic equation. The equation we want to solve is natural log of 6 plus natural log x equals natural log 8 plus natural log of 4x minus 2. So first it says that we're going to use properties of logarithms as well as the property of equality to solve this equation. So first I want to take a look at the property that we're going to be using to solve, and that's the property of equality right here. Some sources call it the one-to-one property of logarithms. So what this property says is that if you have log base b of u equals log base b of v, so that means you have the log with the same base on both sides, then what's inside the log on the left must equal what's inside the log on the right. So it allows you to simplify your equation to no longer having logarithms in it. Well, as we look at this, it requires us to have a single log on the left and a single log on the right. And as we examine our equation, we don't have a single log on the left and we don't have a single log on the right. And that's where these other properties of logarithms come into play. We want to use the properties that we see down here, the product rule, the quotient rule, and the power rule, in order to condense our equation to having a single log on one side. On each side, single log on each side. And so on the left, I can see I am adding two logs together. I'm going to be using this property of the product rule in order to condense. So when you have the sum of logs, you're going to condense with the product rule. I have the sum of logs on the left and the sum of the logs on the right. So I'll be using that product rule on both sides. But just double check before you do that to make sure that your logs have the same base, because you're not able to condense to a single logarithm unless you have the same base. In this example, we have ln, which stands for natural log, and that means that we have log base e. So I'm going to rewrite this equation in its equivalent form. So this equation actually means log base e of 6 plus log base e of x equals log base e of 8 plus log base e of 4x minus 2. I got a little sloppy at the end there. Let's rewrite that. Log base e of 4x minus 2. So we do have the same base on every one of our logs, so we are able to condense and we are able to use the property of equality. So on the left-hand side, I'll condense my logarithms using that product rule to become log base e of 6x. I multiplied 6 and x to condense. And on the right, I have log base e of 8 times 4x minus 2. And now you can see I have a log base e on the left and a log base e on the right. So I can apply the property of equality, and what's inside the log on the left must equal what's inside the log on the right. This gives me a linear equation, which I'll solve. I'll use the distributive property on the right to get 32x minus 16. I want to get the x's onto the same side, so I'll subtract 32. 32x on both sides. That leaves a negative 16x on the right, and on the left I have sorry, I'm having, 6. 26. Negative 26x. And I'll get x by itself by dividing by negative 26 on both sides. And that leaves me with x equals, and I can reduce this fraction. They're both even. 2 goes into 16 8 times. 2 goes into 26 13 times. So we have x equals 8 over 13. Now, when you're solving logarithmic equations, you do need to check your solution to make sure that it's in the domain of the original logarithm. So we're going to check our solution of x equals 8 over 13. In the equation, we have natural log 6 plus natural log of 8 over 13 equals natural log 8 plus natural log of 4 times 8 over 13 minus 2. So I can see that 6 is positive, 8 over 13 is positive, 8 is positive, and I just need to check to see this 32 over 13 minus 2 if that's positive, which it is. 32 over 13 is more than 2, so this will also be positive. So the reason why I'm checking to see if they're positive is because the log of positive numbers is defined, log of 0 is undefined, and log of negative is undefined. So if any of those expressions had a negative inside the logarithm or 0 inside the logarithm, then we would throw that solution away. We will keep the solution of 8/13 because they were all positive. Thank you for checking out my videos. Have a great day.